Okay, we're starting a new unit today, and to get started with this new unit, we need to review some stuff you should already know, which is similar triangles. So after today, you're going to know what that means to be similar and be able to use proportions to find the missing sides of similar triangles and other shapes. Now, what does it mean to be similar? Similar means same shape, different size. So when shapes are similar, their sides are what we call proportional, but their angles are congruent. So, in other words, if you have similar shapes, their angles are the same, but their shapes are similar. Similar shapes equals proportional sides, which means we're going to have to cross multiply. Now, let's take a look at what similarity statements tell me. The similarity symbol is a sideways S, and what it does when you have a similarity statement is it tells you exactly what angles are the same and what sides are proportional. For instance, I'm just going to look at this one today, triangle ABC similar to triangle XYZ. This tells me that angle A, the first one listed, is the same as the first one listed on the second one, so it's equal to angle X. Then the second angle listed, angle B, would be equal to the second one on the second triangle, angle Y, and angle C would be equal to angle Z. Okay? Now, that's the angles, but it also shows you sides. If I look here, it shows me AB is my first side, and that would be similar to XY, the first two letters. Then I could take the last two letters, BC, and it would be similar to the last two letters in the second triangle, YZ. Finally, the first and the last, AC, would be similar to the first and the last of the second, XZ. Okay? So, the order that you write your similarity statement in does matter and is very important you get the order correctly so that your corresponding angles, the congruent angles, are listed in the same order. That way, your proportional sides are also listed in the same order. So now let's review some cross multiplication. If I cross multiply this one right here, I'm going to get that x equals 3 times 2, so x would be 6, right? If I did this one, x squared would equal 4 times 9, so x squared is 36, so x would end up being 6, okay? But cross multiplication does get a little larger, as you can see. It does get a little more entailed. For instance, this one right here, I would have to 5 times x minus 8 equals 6 times x plus 2. Distribute my 5 and my 6, so 5x minus 40 equals 6x plus 2. Subtract your x over, subtract your 2 over. Oh, that's 12, sorry. Subtract your 12 over. X would be negative 52. If I did the same on the second one, a little more intricate here. X times 3x minus 3 equals 2x minus 2 times x plus 2. Okay. Distribute 3x squared minus 3x equals 2x squared plus 2x minus 4. Get everything on one side because this is a quadratic. So I'd get x squared minus 5x plus 4 equals 0. factor this down. Factors of 4, that would give me negative 5. Well, that's just 4 and 1, both negative. So in this instance, I get two answers. X could be 4 or X could be 1. Now, if I look back at my original statement, if I plug in a 1 right here, this is going to go to 0. Your denominator can never be 0. So 3 times 1 is 3, minus 3 is 0. That would negate X being 1. So my answer would simply be X is 4. Alright, so now let's take what we know about proportions and we know about cross multiplication and similarity statements, and let's start solving some similarity. For instance, here, I'm going to make A be X and YZ be my Y, and we're going to solve for each one of these. The first thing you need to do is figure out what sides are similar. Another way you can do that is mark your congruent angles. This tells me that A is congruent to X, tells me that B is congruent to Y, and that C is congruent to Z. If you notice, I'm using different colors for a reason. Okay? So X is AB. So X is congruent to purple and red, 21. X is similar to 21, as 8 would be similar to 24. So 24x equals 168. Okay. Divide that by 24. X would be 7. Same thing with the Y. Y is on the here. So red and blue is to 10, as 24 is to 8. So 8y equals 240. So y would be 30. Simple enough. Moving on. Again, I'm going to label my sides X and Y. I see that 50 is to 10. Now, when you set up your proportions, remember, if I start on on XYZ, I need to start on XYZ on the other side of my proportion. So 15 is to X. So 50x equals 150. X would be 3. Again, I'm going to do 50 is to 10, as Y would be to 12. That would give me 10y equals 600. So y would be 60. Okay? Just a couple more. Now, they don't give us the triangles on this one, so you must draw them in. So I'm just going to draw two triangles here. Doesn't matter what they look like. JKL and TUV. Okay? They tell me JK is 10, KL is 15, TU is 30, and TV is 33. They want me to find the missing sides, so I mark them with an X and a Y. That way we don't get them confused. Then we keep going. So 10 would be to 30, as X would be to 33. So 30x equals 33, 330. X would be 11. Do the same thing. 10 is to 30, as 15 is to Y. 30 times 15 is 450, so 10y equals 450, so y is 45. Okay. Last one, I have triangle ABC, and triangle TRS. Okay. AB is x plus 2. BC is x plus 1. AC is 5. TR is 3x minus 1. And RS is 2x plus 2. On this one, they want us to solve for x and find TS. Okay? So in order to do that, we're going to have to set up a couple of proportions. So I know that AB is proportional to TR. So x plus 2 is proportional to 3x minus 1. And I know that BC is proportional to RS, so x plus 1 is proportional to 2x plus 2. So cross multiply x plus 2 times 2x plus 2 would equal 3x minus 1 times x plus 1. This gives me 2x squared plus 6x plus 4 equals 3x squared plus 2x minus 1. So x squared minus 4x minus 5 equals 0. So I'm going to factor this out. X minus 5, x plus 1. This would give me x is negative 1. I cannot have a negative length. And if I put negative 1 into BC, it would give me 0. And then x equals 5. So x is 5 is one of my answers. Now they want TS. Okay, well, 5 is to TS as, and I can choose either one of these. I'm going to choose AB. So 5 plus 2 is 2. 3 times 5 minus 1. Okay. So 5 plus 2 is 7. So 7 times TS equals 5 times 14. So 7 times TS equals 70. So TS comes out being 10. Okay, so there is your brief recap on similarity. I hope it made sense. I'm sorry it's so sloppy. I'm using a new program and writing on it is a little hard. Hopefully it will get better over time. Again, if you have any questions, I will be back tomorrow. I hope this was beneficial.